Christoph Montag speaking. Working at ArianeGroup as a system engineer, basically the technical expert for our RIT2X. Next couple of slides and couple of minutes, I will present on how actually the RIT2X works. What is the RIT2X? I will specify a little bit more on the test campaigns we had. For one, the function and performance test campaign done in Giessen, and also on the EPS test campaign. Just a quick overview and conclude with achievements we have done within the project GIESEPP MP. So the RIT2X basically consists of the thruster itself on the bottom right. It has a neutralizer and is driven by the radio frequency generator. You can see on the top right, connected by a RF harness. And main goal in that project was to achieve a TRL 6 to 7 on thruster level. We have done the performance and functional test, also the EPS test, and a typical mission profile for our thruster for our product is a MEO-GEO mission, or also interplanetary missions like, for example, MSR mission. So how does the RIT2X work? On the top right, you have a sectional view of the thruster, where you can see that you have the gas flowing from the rear of the thruster into a vessel. And that vessel is surrounded by a coil, and that coil is basically connected to our radio frequency generator. And having that alternating electrical field ionizes our xenon, and the ionized xenon, the ions are accelerated by the grid system, creating the thrust, and the neutralizer basically collects the electrons from inside the vessel, neutralizing the thrust beam, so we don't have any charged spacecrafts or whatsoever. What are the advantages of the thruster system? For one, it is scalable, has a high efficiency, and it has a perfect thrust control by adjusting grid voltages, for example. What is the operational range of our thruster on the left side? So basically, it can reach a thrust up to 255 millinewton, a ISP of up to 4,500 seconds at a power of up to 8.5 kilowatts. So this is the overall operational range for GIESEPP. You can see the actual operation points, station keeping and orbital racing. So it's within the frame of the actual range. So for station keeping would be like 108 millinewtons at 3,400 seconds, and for orbit racing up to 203 millinewtons and 2,700 seconds. Yeah, we were mentioning the two test campaigns we had this year. Beginning of the year, the performance and functional test campaign at JLU, our colleagues at the University in Giessen. So we were performing the test campaign there, validating the operation points of our thruster in their facility. They have a newly installed test power supply, and this was done pretty nicely and gave us the opportunity to have conditions best adjustable for the thruster. We did some performance mappings, plasma diagnostics, and I think my colleague Konstantin will talk about it a little bit more detail. And the second campaign was the EPS test campaign, where we had a flight-like setup with a PPU, fluidics, and the thruster itself. There we had fewer degrees of freedom, and therefore a much more complex system and conditions to run the whole system. So what were the objectives for the function performance test? For one, we had to validate our operation points, not only by calculations or analysis, but by test to see if the thruster can handle the station keeping and orbit racing OPs, and verify basically the capability of the thruster RIT2X. As said, there was a new EGSE setup, and the test sequence we were running, or usually running, is having a reference operation point in the beginning of a campaign and at the end to verify that nothing had changed on the thruster, and from there going through the specific OPs, including measurements, in this case from station keeping low power, full power, to orbit raising low power and full power. What have we received and achieved there were thrust ranges between 95 to 203 millinewtons and a specific impulse between 2,700 and 3,400 seconds. There were some investigations done on perviance measurements, where you basically adjust grid voltages, and also electron backstreaming tests. Everything was within limits. As you can see on the right-hand side, for all OPs, we had the status of compliance. So we achieved full compliance in that test campaign, resulting to a successful test at JLU. For the electric propulsion system test, the EPS test, it's a broad overview. Colleagues from Airbus and Aerospazio will talk about it in detail. So basically, we had a test with GIESEPP PPU, the flow unit from ADS, our thruster. So there we could consolidate the thrust operational points in a different test facility, having an interlaboratory comparison. Once on full system level, flight-like, compared to a laboratory setup, I'd say, with an EGSE. Boundary conditions were that Airbus was the prime there, the test lead. Test was conducted here in Aerospazio, Rapolano. We had performed the test in October, and extensive performance mapping, E cross B, RPA, and Faraday probe measurements were done to characterize thruster plume, thrust, ISP, etc. So what was achieved on thruster level within the project? For one, we had extensive discussions and communications with our satellite prime Airbus to meet market conditions and needs within specification and to be compliant to their boundary conditions. There was the thruster performance and functional test in Giessen, where we validated the operational points, station keeping and orbit raising. And there was the recent campaign, the EPS campaign, here in Rapolano, where we had a coupled system, again verifying the OPs on a different setup, on a different facility, leading to the fact that the overall thruster system reached a TRL 627. Yeah, that's it basically from my side.